Alright guys, so today we're going to start off by reviewing the concept of absolute value. So if you haven't heard that in a while, a little reminder, absolute value is a value's distance from 0 on the number line, and absolute value is a positive value because it is measuring distance. So we don't have negative distances, so it's always going to be positive. Doesn't matter which direction it is, it's going to be the same distance. And so that's why if we take a look at examples 1 and 2, the absolute value are these vertical brackets here around the numbers. And so we say the absolute value of 3 means how many spaces from 0 on the number line is 3. If you were to actually take a physical number line and count back from 3 to 0, 3 to 2, 2 to 1, 1 to 0 is 3 places. So the absolute value of 3 is 3. Now, that actually also works when dealing with negatives as well, because if I have a number line here, let's draw it real quick, and I have negative 3 here, negative 2, negative 1, 0, and negative. So if I'm talking about the absolute value, if I'm starting at negative 3, to get to 0, I'm still moving 1, 2, 3 places. It doesn't matter which direction, it's a movement of 3 places. So we say that the absolute value of negative 3 equals 3. Obviously, if I'm talking about 0, I'm not moving any places to get to 0 on the number line, so I'm moving 0 places, so my absolute value is 0. Number 4, it's a little bit trickier because we have a negative sign outside of the absolute value. It's important to remember that absolute value acts as a grouping symbol. So we have to do everything that's inside this grouping symbol of absolute value before we do anything with this negative. So I'm going to evaluate it from inside out here. So I've got the absolute value of negative 2, which I know is... Alright guys, sorry about that. So as I was saying, if I know to evaluate the inside out first, if I evaluate the absolute value of negative 2, I know that that is 2. And then if I see the negative outside, then I apply that, and so this becomes negative 2. So absolute value itself is always negative, or is always positive, excuse me, always positive. Absolute value is always positive, unless there's a negative sign out front that we apply after we evaluate the absolute value inside the brackets. So I'm going to have you guys work on this example here. I want to know what is the absolute value of negative 4.25. Alright, so hopefully you realize that with this one, all you have to do is remove the brackets and make this number positive, and you get an absolute value of 4.25. Alright, so today we're going to talk about measures of dispersion, and measures of dispersion measure the spread in a set of data. So the first one we talk about range, and that is the difference between the greatest value and least value, and it gives the length of the interval, and we know the difference means subtraction. And so I'm going to add these here. You can see that they're ones. And so if I took a look at the data from yesterday, and I think the biggest value was 172, and the smallest was 1. So if I take 172 minus 1, that gives me the range, or spread from least to greatest value, and that's a distance of 171. When I'm calculating absolute mean deviation, that gives me the average variation of the data to the mean. So each value has variation to the mean. It's the distance from the mean value. The absolute mean deviation is going to give us the average of all those distances. So it's going to tell us a little bit more about how spread out the data is. All right. So if I'm looking at points scored in the 2015 Elite 8 round of the NCAA men's tournament, I want to find the range and absolute mean deviation. The first thing I tend to do is go through and start putting my numbers in order from least to greatest. And so in this case, I started out, I did 52, 66, 66, 68, 70, 76, 78, and then my last one here is 85. And then we'll do a quick check just to make sure we got them all. 1, 2, 3, 4, 5, 6, 7, and 8. That's correct because it's the Elite 8. And so if I want to find the range, I have to know, back to that vocabulary, it was the greatest value minus the least value. So I want you guys to try to identify that first. Alright, and so hopefully you guys were able to see that 85 was our greatest value and 52 was our least value. So if I do 85 minus 52, 5 minus 2 is 3, and 8 minus 5 is 3. So my range equals 33. So my range equals 33 because that is the distance from here down here with the least and the greatest. Alright, so next we're going to calculate the absolute mean deviation. And so first we want to kind of go over the formula for absolute mean deviation. Alright, so here is our formula for mean absolute deviation. And so we notice a couple things that we've learned recently. The absolute value brackets are here, and also we see this x bar. And so what this means is if we have an n number of values, so however many numbers we have, and in this case 1, 2, 3, 4, 5, 6, 7, 8, this n would be 8. Okay, so it would be x sub 1, x sub 2, blah, 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 add it all the way up. And the last one would be 8. So what we'll be doing is we see this x bar here, okay, and so hopefully from yesterday you remember that that means average, okay. So what that tells me is at some point we are going to need to calculate the mean, and so that might be a good place to start. But after that we see we're going to take each value, subtract the mean, and then take the absolute value of it. And the reason we're going to take the absolute value of it is because if we end up with a negative number, we want it to be positive. So taking the absolute value at the end of it will eliminate any possibility of a negative number. And so then we will add all those things up and divide them by the total number we have. So again, taking the average again. So we're taking the average of the distance for each data value to the original average. And so let's start this off by trying to find the average. And I'm going to let you guys find the mean or the average for this data set up here, 52 through 85. Go ahead and find the mean. And as a reminder, that means we add all these up and divide. Alright, so hopefully guys added these up and you came up with the number 561. And I guess we should say that we're calculating x bar. So x bar equals 561. And we're dividing that by the number we have, so 8. And that gives us a mean or x bar of 70.125. So teams in the Elite 8 round of the tournament, in the men's tournament, averaged 70.125 points per game. So we now know our x bar. What we need to do now, though, is figure out the difference between each value and the average. And so one way to do this is to go through and we'll say, we'll fill in these values. So the first one, if I take my absolute value of x sub 1, that's this guy right here. So this one is x sub 1. Move this up just a little bit. We'll start labeling x sub 1, x sub 2, so on and so on. And we realize that this one is x sub 8. So 3, 4, 5, 6, and 7, all the way up to 8. And so I'm going to take that x sub 1 value, and that was 52, minus, and then we have our x bar. So our x bar is 70.125. Now, one thing you might notice is that 70.125 is bigger than 52. That's the whole purpose of the absolute value bracket. So what I'm going to do is calculate that value. And what I got was negative 18.125. So when I take the absolute value, that's 18.125. So what I'm going to end up doing is repeating that for all 8 of the values, or the remaining 7. I'll do 66, but you notice on the ones that are double, you would only have to do it one time. So the next one you're going to do is going to be absolute value of 66 minus 70.125. And then you guys are going to calculate that absolute value, and you're going to do the same with the remaining values, and then I'll catch up with you after you do that, after this little break. Alright, so hopefully you guys came up with the same values I did. Remember, I don't have any negatives here because when I take the absolute value, that's going to eliminate the negatives. So now that I've got these absolute value pieces, and again, that's just these guys up here, each one of these is one of these guys right here. So we have a total of 8 of those values, all the ones in there. Alright, and what we're going to do is divide it by the number that we have. So since we have 8, we're going to add all of these up and divide it by 8. So why don't you guys go ahead and do that now. Alright, and so if you guys add this up, what I came up with was 57.25 divided by the total that we have, so 8, and that's going to equal, and I'm going to round it to 3 decimal places, so 7.156 is our absolute mean deviation, and what that means is, on average, the data, each piece of data is an average of 7.156 from the mean. Alright, in this example we are looking at biodiversity in Central America if we're considering terrestrial vertebrates, meaning land animals that have backbones, so terrestrial vertebrates. And so if we're looking at the countries of Central America here, and I want to find the range and absolute mean deviation of reptile species in Central America. Reptile species is right here. So that means the numbers I'm going to work with are these ones right here, following this column. And these are the only ones I'm going to consider. So I want you guys to take a minute and calculate that. Alright, so hopefully you guys were able to see that our biggest value was 258. Our greatest value was 258, and then if we're looking here through the smallest for the least value, we see there's 106 in El Salvador. And so when we calculate our range, we come up with a range of 152. Now I want you guys to find the absolute mean deviation on this one, and show me your answer when you are finished. Once you show me your answer, you can get the worksheet for today and finish it up for homework. If you have any questions, please just ask.